High-performance computing, or HPC, is about solving big, complex problems by using powerful clusters of computers working together. Instead of relying on a single machine, HPC systems divide tasks across many processors, letting scientists, researchers, and students run simulations, analyze data, and train AI models at speeds that aren't possible on a single system. Here at CloudCIX, we've built a new HPC platform as part of the new Boole Supercomputer. It's designed to make high-performance computing accessible and flexible. Whether you need a quick test environment or a massive GPU powerhouse, Boole has you covered. Let's get started by going to hpc.cloudcix.com and logging in. On your first login, you'll be prompted to create a home directory. Simply click the Open Shell and Create Directory button, and you will be brought to the terminal. You can close this tab, and once you've done this, you can click I've created and refresh the page. We're now at the Boole Supercomputer HPC dashboard. The dashboard gives you everything at a glance. Here you'll see pinned apps for quick access, cluster status and resources. Using the icons or the navigation bar, it's easy to move between your file browser, the terminal access, active jobs, or any of the other interactive applications. One of the great things about our HPC platform is that your home directory is shared amongst all cluster nodes. That way you have access to all your files, no matter where you're running a job. Let's start by having a look at the Files app. The UI makes it easy to upload any existing data you may already have. To download, simply click on the directory you want and click the Download button. For command line workflows, the shell interface puts you right inside the cluster without needing to configure SSH. SLURM is the workload manager that schedules jobs on the cluster. We're going to cover all the basics here so you can get started straight away. Let's open a shell and run the command sinfo. This tells us all the nodes or partitions that we can run jobs on. The srun command is a great way to run interactive sessions. Let's go through an example here. The partition flag allows me to choose which node I'm going to use, in this case the cloud. I'm then using the CPUs per task to 2, so setting 2 CPU cores. I'm specifying memory to 4 gigabytes. The time flag for how long I'd like this session to last, and the sudo terminal bash so that I can interact with it. You can see that my terminal has now moved over to the compute 2 node in the cloud. The great thing about the HPC platform is that your home directory is available on all nodes. So now in the compute node, I can still see my files. Let's run a test script here. For computation heavy tasks, just request the resources you need and let Boole take care of the rest. Up until now, we've been running jobs interactively with srun, but for longer, more complex workloads, the recommended way is to use a batch script. A batch script is just a regular shell script with extra sbatch lines at the top. These lines tell SLURM how to schedule the job. For example, how many CPUs you want, how much memory, which partition to use, and how long the job can run. To submit this job, you can use the sbatch command followed by the name of the script you wish to run. It'll then be added to the queue when resources become available. Let's take a look at the results now by catting the output file. SLURM can send you emails when your job starts, finishes, or fails. Add these options to your script. Our HPC environment uses spack to manage packages. Run the modules available command to see what modules we have available. You can now see all the packages we have installed on the cluster. For this example, let's try loading a version of Python 3.11.9. Use the module load command. And then the module list command will tell you every package you have installed. For Python environments, we recommend installing Miniforge in your home directory. This lets you create isolated environments for different projects. We have a full guide available in our documentation to walk you through this. Just follow the link in the video description. Let's start by activating Conda. Next, let's create a virtual environment called myenv. It's going to grab all the packages it needs. And when that's done, we can start installing our own. Use the conda install command followed by the name of the package you want to grab. For this example, I'm going to grab numpy, scipy, and matplotlib. You can also use the pip install command to install any packages you may need. Here I'm grabbing the pandas and seaborn libraries. On our HPC platform, we use Apptainer as the backend for working with containers. This allows you to run Docker images securely and effectively across the cluster. Let's start up an interactive session on the cloud. And then let's use Apptainer to pull the Hello World Docker image. You can see here in our home directory that we now have the Hello World latest SIF image. Using the Apptainer run command, we can then run the image that we just pulled. And there's the output. We're especially proud of our ever-growing catalogue of interactive apps. Our goal is to make HPC easy to use and accessible. Right now we've got things like Jupyter Notebooks, the AI Lab, and Remote Desktop. Let's start a Remote Desktop session from the pinned apps. This is a great option for GUI-based workflows. We set our resources here in the form and select which partition or node we want to run the job on. And when we're ready, click Launch. When your session is ready, its status will turn green and it'll say running. Click Launch Remote Desktop to start the session. We now have a full Linux-based desktop environment directly in our web browser. And just like the shell view, you have access to all your files here too. When you're finished with the session, you can just close it and click Delete. Up next is the CloudCIX AI Lab. This application allows you to run and interact with both large and small language models seamlessly on the HPC platform. There's a huge amount of options to go through here, but as a general overview, I'll go through some of the basics. There are both chat and instruct interfaces for interacting with your model. The notebook section allows for extensive testing, and the parameter page allows you to tweak your models extensively, from temperature to token limits. You can even define the agent's personality. You can load models directly from your home directory, or grab any model available on Hugging Face, and the app will download and import it for you. Let's walk through the process now. You can see here I'm grabbing a simple 2 billion parameter thinking model, but with Boole's collection of A100s, H100s, and even B200s, you can easily run 600 billion parameter models with ease. Let's test out the UCCIX bilingual Irish and English model and test out some questions in Irish. I can immediately begin interacting with the model after it loads. Let's ask a few questions about cloud computing. Because this runs as a dedicated HPC job, it doesn't share resources with other users, resulting in consistently fast, low latency responses. Now, how about the question in English as well? Finally, here's a look at Jupyter Notebooks running on the HPC platform. This is a great option for real-time data analysis, visualization, and experimentation. If at any point you need a reminder or help on how to use our HPC platform, we have a comprehensive guide in our documentation. Simply click Help in the top right corner and go to Online Documentation. Here you can see the full user guide for the HPC system, including everything we covered in this video. If you need additional technical support, please reach out to us at support@cloudcix.com and we'd be happy to help. I hope you found this video useful as you get started with our HPC platform powered by the Boole Supercomputer. We're excited to see what you'll create, discover, and achieve using this platform, whether that's running advanced simulations, analyzing data, or training the next generation of AI models. Log in today at hpc.cloudcix.com and let us know how we can support your research and projects.